And we're live. Hello, everyone. My name is Alex, and I'm a sales engineer at Alpes Lasers. Today, I'll be giving you a brief overview of our mid-IR products. So let's get right into it. The structure of the talk will be a brief company presentation, followed by our laser sources, then the mounting and packaging that we offer. We'll end it on projects and custom systems, and if you would like to ask us any questions afterwards, you can either visit us at our booth or send us an email at sales@alpeslasers.ch. So, Alpes Lasers. We're a Swiss engineering and manufacturing company based in Neuchâtel in Switzerland, and we pride ourselves on being the first company to produce quantum cascade lasers back in our founding in 1998. We're innovation driven with a high level team of experts, so we have around 20 PhDs in optics in the company, and our intellectual property rights span over 2 decades with 12 major patents in QCLs. Onto our laser sources. So I've split them into 3 broad categories: single mode lasers, multi-mode lasers, and high power lasers. So for single modes, you have your typical distributed feedback lasers, but we also have our own special design called QCXT. For multi-mode, we have Fabry-Perot's, broad gain lasers, external cavity lasers, and frequency combs. And high power lasers, we have a special category of multi-mode lasers, which go up to 1 watt and beyond. Down here, I'm showing you a spectrum of where we operate. So we do have terahertz lasers in the far IR and also shortwave infrared diodes. But this talk is going to be focused on the mid-infrared. So we'll be talking quantum cascade lasers and interband cascade lasers. So single mode QCLs. What we can expect here, briefly, is wavelengths in the range of 4 to 16 microns, optical powers between 1 and 100 milliwatts, although we can go higher, but we'll have to discuss it on a case-by-case basis. Line widths in pulse operation of 300 megahertz, or in continuous wave of around 1 megahertz. We also offer intermittent continuous wave operation. We'll have to discuss that separately. It's a bit different from either pulsed or continuous wave. And we have operation at room temperature or cooled. In this case, I mean, it'll operate at room temperature, but the packaging will probably have a thermoelectric cooler, Peltier inside it. And when I say cooled, I mean it can be down to cryogenically cooled, especially for the very long wavelengths. We also expect to have 8-week lead times, especially if it's in packaging. If it's already in stock, prepackaged, we can go down to maybe 2-week lead times. And here you can see me holding one of our lasers in HHL on an HHL heatsink while wearing the Alpes Lasers mask and the infrared safety goggles. For multimode QCLs, we can expect optical powers between 1 milliwatt and 1 watt. And once we get to the 1 watt area, we're in the category of high power lasers. And the wavelengths, again, in the range 4 to 14 microns. Another multimode laser, we have our broad gain devices with around 250 wave numbers in spectral width. And these are also 8-week lead time in packaging. On the bottom left here, you can see an example of a high power QCL in HHL going up to 1500 milliwatts average power. And on the bottom right, you can see one of our broad gain QCLs. This is the 5.1 to 6.1 microns operating in our external cavity. So this can reach a range of around 1630 wave numbers to around 1980 wave numbers. And our newest product, one thing that we're really glad to introduce, are our new interband cascade lasers. So the wavelengths in the first iteration, at least, are 3.2 to 3.6 microns, and the optical powers we expect are around 10 milliwatts. In the first iteration, because these are new, we only have broad gain lasers, and later on, we're going to be manufacturing single mode lasers. So these are distributed feedback ICLs. 8-week lead time again in packaging. And here I'm showing you an example of the performance in our external cavity again. So you can see we're going from around 2,800 to 3,100 wave numbers. room temperature operation, and continuous wave. I mentioned the QCXT. This is our special Alpes exclusive. This is a special kind of single mode laser where we use the Vernier effect in order to select different regions within the comb in which we can operate in single mode. So we describe it as DFB performance with extended tuning. And we have high powers greater than 100 milliwatts in the continuous wave. It's highly compact, so this is all done on a single chip. And it effectively acts as several lasers in one. So just to show you how it works, you have one laser chip with two heaters on it. You have a front heater and a back heater. And the way it works is that by powering these heaters by different amounts, you can activate different regions, as we can see here, in which it'll operate as a single mode laser. So with the front heater fully powered and the back heater not powered, you activate this region in which you operate between around 1250 to 1255 microns. You can change the settings on the heater, so you can operate all the way up here in around 1290 to 1295, not microns, wave numbers. So you can see this has effectively a large range, but we call it large piecewise tuning because you have to select it within these specific regions. But this solves the problem where if you have a single mode laser and you're right on the edge and you wanted to grab an absorption line just to the right of it, you can't put any more power into it. You have to actually buy another laser in order to get into these other regions. So that's really cool. Send us a message if you want to know more about it. So for our mounting and packagings, first we start with the different submounts and non-packagings that we offer. Bare chips. Obviously, we can offer our lasers in bare chip. This is uncommon, but if you have a high volume application, this is probably ideal for it. And we provide these in gel pack, but we can only test them in pulsed mode. The second option is lasers on aluminum nitride submount. And these are tested in pulsed and continuous wave operation. Because it's on aluminum nitride submount, it has improved heat transfer, and it's small enough that it can easily be integrated into any products. More common is to get an aluminum nitride submount with a laser on it on a copper submount. And this also has good thermal properties. It includes screw mounts. It's a bit easier to handle. And in our LLH, laboratory laser housing packaging, it's easy to just put it in and screw it in, and you can take it out and replace the laser as needed. We also have many different copper submounts depending on the geometries that you need. Okay, so now for packagings, we have three main types of packaging. We have TO3 cans, and these can be included with the lens or without. And we can expect up to 3 watts thermal and dissipation. And here are some dimensions, just so you can see the relative size. For shortwave infrared, we use TO66. And this will also include integrated TEC. For our flagship packaging is the HHL. This is the most commonly requested one. And this includes TEC, built-in TEC, and a lens. And we can expect up to 15 watts of thermal dissipation. Here's some dimensions. And specifically for the HHL, we've developed a custom heat sink, which also has water cooling available. Our final packaging is the laboratory laser housing, the LLH. And this has a window and a TEC, but we don't include a collimating lens in this one. That's because it's designed such that you can easily replace a laser chip inside the housing. So you can unscrew it and change the laser inside. You'll have to do some realignment, but this makes it easy to test multiple lasers. And it has a built-in water cooling circuit. You can see here some tubing. It's a bit larger, but this is what you need if you're going to be getting multiple lasers and you want to try them out in a laboratory setting. Onto components and custom systems. So I mentioned before we have a laser cavity system. We call this our external cavity laser kit. And we can provide these. These include the drivers, the temperature controllers. So like you'll have all of that, and you'll only need to get the lasers on a sub mount which are compatible with it. And that's normally a broad gain laser, so you can sweep over a wide range. We also have pigtailed lasers. You can see an example of a pigtailed HHL here. So you would just add the fiber. And we have high compliance laser drivers. Let me just move this. Here's an example. This is our S2 QCL pulsar. We also have an S3 QCL pulsar with similar specifications. And HHL heat sinks, as I mentioned before. You can see here on the pigtailed one, an old version of the HHL heatsink with the water cooling circuit. Now on to R&D projects and custom systems. So over the past 4 years, we've raised over 11 million euros of project funding. And this is crucial because this allows us to produce new products and also explore different photonics applications. We're currently participating in 15 active EU grants, thus making us the most active SME in Switzerland. And honestly, this is ideal for developing custom systems with specific needs, because this way it's more accessible because you have the funding available. You don't have to worry about putting your own capital in. You can try to get a grant. And then if you have a very good idea, that grant will get funded and we'll be able to help you develop it together. So here I'm showing you some of our projects that we're currently involved in. Some as a lead investigator and others where we're a participant. And I'm going to go more deeply into one of them, Hydroptics, that we're very proud of. And this is just to show you that custom needs can be met with new systems. So in Hydroptics, they had the specific need to develop a QCL beam combiner. They needed to combine 2 single mode lasers. They also needed to combine 2 combs, which is also an interesting thing. Here you can see on the bottom left the prototype they created for the Hydroptics project in order to combine the beams from 2 different combs. And they also have a single mode laser beam combiner. And you can see it combines very well. You get a very nice spot. And this was for a very specific use case that they had for measuring pollutants in water. And again, we offer our expertise and manufacturing capabilities. So like everything here was manufactured in Alps. So the lasers, we sourced the parts and we did the beam combining. We also provided our expertise in order to develop this, to design it. And this is the kind of thing that we can do. We've also done this for other projects where we're the lead. So we're always looking for partners for new projects. Please contact us, come to our booth. We'll discuss this more. We have a business development team that's very excited to connect with you and see what we can make in photonics. And that's all I have to say for now. Again, please visit us at our booth or send us an email at sales@alpeslasers, and we're looking forward to working with you.